When we're working with different kinds of lines, there's two kind of special types of lines. We can have parallel lines or we can have perpendicular lines. And you see both of those graphed on these two graphs below in example 145. 145 are parallel lines, they never cross each other. And the next one are perpendicular lines. They cross, and they cross at a 90-degree angle, at a right angle. And so we're going to kind of look at some of the characteristics of these parallel and perpendicular lines, specifically their type of slope. So let's start with our parallel lines. I'm going to find the slope of each of these lines. I'm going to draw two little slope triangles here. For the top one, I go down 2, and I go over 3, so my slope is negative 2 over 3. The slope of the first one is negative 2/3. And the second one here, I go down 2 over 3. The slope of the second one is also negative 2/3. You probably could have guessed that just by looking at the lines. So one characteristic about parallel lines is they never cross because they have the same slope. So we're going to write right here, parallel lines have the same slope. If they had even a tiny bit different slope, eventually they would cross each other. Okay, so let's look at perpendicular lines. Obviously, these do not have the same slope, but they still have a very special kind of slope. So let's draw our slope triangles and count our rise and run here. So for this first one, we go down 3, right 2. So negative 3 over 2 is our slope. For our second one, we go up 2 over 3. So our slope of this one is positive 2/3. Okay, so if we compare those, we have negative 3/2, positive 2/3. Those are called opposite reciprocals. They are opposite signs. One is positive and one is negative, and they are reciprocal fractions. They are flipped fractions. So perpendicular lines have opposite reciprocal slopes. They're opposite signs and they're flipped fractions. So knowing that information about these kind of lines, we can use that to answer some questions. So example 146 says find the slope or the m of a line that's parallel to this line right here. Well, we know parallel means that our slopes are equal, that our slopes are the same. So to find the slope of the line we're looking for, we've got to know the slope of this one. I'm going to do that by solving for y equals mx plus b. We can move our x's over, and we get 5y equals 2x plus 7. If we divide both sides by 5 to isolate the y, we get y equals 2/5 x plus 7/5. We're only concerned about our slope because we know our line is parallel to this, so that means our line also has a slope of 2/5. If they're parallel, our slopes are going to be the same. Okay, on example 147, they ask us to find the slope, again, which is the m, of a line perpendicular. So not parallel, perpendicular to this equation right here. 3x minus 4y equals 2. Okay, so we got to figure out what is the slope of this line first. We're going to solve for y just like we did on the last one. Move our x's to the right side. And we end up with negative 4y equals negative 3x plus 2. To get y alone, we can divide both sides by negative 4. And we get y equals negative 3 divided by negative 4 simplifies to be positive 3/4 x. 2 divided by negative 4 gives us minus 1/2. And really, we don't care about what that number is on the end. We just care about what the slope is. So if the slope of this line is positive 3/4, the perpendicular slope, and notice I'm going to use this symbol right here, the perpendicular slope, it's like an upside down T, it's going to be the opposite reciprocal. It's going to be a negative, then we flip our fraction, negative 4/3. Okay, so we can also use that to help us write equations of lines. So example 148 says find the equation of a line that goes through this point, 4, -5, and is parallel to 2x minus 3y equals 6. Okay, so we know our point. I'm going to call this x1, y1. But we don't know our slope. We're going to have to use this equation right here to help us see what slope we want our line to have. If we know it's going to be parallel to this, it's going to have the same slope, or the same m. So to solve for y, I'm going to do minus 2x. And I get negative 3y equals negative 2x plus 6. If we divide both sides by negative 3, we get y equals 2/3 x minus 2. We only care about our m, we only care about our slope, so we know that we want our line to also have a slope of 2/3. Okay, and notice here they just asked me to find the equation. They do not say that it has to be in slope-intercept form, so once we use point-slope formula, we can leave it in that form. Don't forget, point-slope formula looks like this. Y minus y1 equals m times x minus x1. And we're going to replace the y1, the m, and the x1 with the values right below. So I have y minus -5, or y plus 5, equals m, 2/3, times x minus 4. They don't specify that we need to put this in slope-intercept form, so we can leave it just like this in point-slope form. Okay, example 149 is similar. We want to find the equation of a line that goes through this point. I'm going to label this x1, y1, and is perpendicular to this equation right here. Well, luckily, they already have this in slope-intercept form. So we already know that the slope of this line is -3/5. If we want our slope to be perpendicular to that, we're going to find the opposite reciprocal. It's going to be a positive, flip the fraction, positive 5/3, positive 5/3. Okay, let's use the point that they gave us and this slope to write the equation of our line. We've got y minus y1 equals m, which we just said is going to be 5/3, times x minus x1. This one they specify that we do want it in slope-intercept form, so let's go ahead and isolate y. We're going to distribute our slope. We have y plus 9 equals 5/3 x minus 10. 5/3 times -6 gives me a -10. To isolate the y, we're going to subtract 9 from both sides, and we get y equals 5/3 x minus 19. All right, and then our last one here. Instead of using point-slope formula, we're going to kind of just problem solve our way through this one. It says find the equation of the line that goes through the point 3, 4 and is perpendicular to the equation x equals -2. So let me draw a little coordinate plane over here. Here's your x-axis, here's your y-axis. Don't forget that this equation right here, x equals -2, means it crosses my x-axis. It's a vertical line that crosses at -2. That's this line right here, x equals -2. So if we want a line that's perpendicular to that, we want a horizontal line that's going to go through the point 3, 4. So let's just kind of sketch over here. The point 3, 4 is somewhere around here, and we want it to be horizontal because those are going to be perpendicular. So if we have a horizontal line, our equation looks like this. Y equals just a plain old number. And since it's going to go through this point, 3, 4, it crosses our y-axis at 4. So we have the equation y equals +4. We would get the same thing if we went ahead and used the point-slope formula. We would just say that the slope that we want is 0 because we want it to be a horizontal line. So that's how we can use the concepts of parallel and perpendicular lines to help us either find slopes or write equations of specific lines.